Hi guys, welcome to my channel. Please try to watch till the end so that you capture everything that I'm going to teach. So today's question is WAEC 2002, 2006, number 8 AI for candidates in Nigeria, Sierra Leone, and Gambia. It says, draw the energy profile diagram for the reaction. This is the reaction where hydrogen gas combines with iodine vapor to form hydrogen iodide gas. The enthalpy change of the reaction is minus 30 kilojoules per mole. To solve this kind of question, the question says, draw the energy profile diagram. Energy profile diagram is just a diagram that shows the enthalpy transition or heat transition between the reactants. From the reactants to the product, the heat transition that occurs as reactants combine to form product. Now, one thing you should know is that once the enthalpy change, which is the difference between the enthalpy of the product and the enthalpy of the reactant, once the change is negative, the reaction is exothermic, which means heat was lost. So we have two types of energy profile diagram. Two types. Where here, this axis is reaction pathway. Reaction pathway. And this axis is the energy axis. Now, in this profile diagram, it shows what happens from product, from reactant to product. So this is where reactant is, this is where product is, and this is an activated complex. So the energy of the reactant is now greater than that of, the energy of the reactant is greater than that of product, correct? Therefore, heat change, which is enthalpy change, the formula is actually enthalpy of the product minus enthalpy of the reactant. Now, if the enthalpy of the product is less than the enthalpy of the reactant, it means that the heat change will be negative. So this profile diagram is for exothermic reaction because the heat change is negative. But here, this one is different, where the enthalpy change of the product is greater. The enthalpy of the product is greater and that of the reactant is smaller. Therefore, enthalpy change will be HP minus HR. That is, if the enthalpy of the product is now greater, it means that change in enthalpy will be positive, and that is endothermic. Endothermic. And this is exothermic. So what we are going to draw will look like this for this reaction. So let's draw it. Let's draw it. Let's draw it. This is the axis for energy. Energy axis. This is the axis for reaction pathway. Reaction pathway. So looking at the value of the enthalpy change, which is negative, the shape is going to be like this, where the enthalpy of the reactant will be bigger than the enthalpy of the product. And what are the reactants? What are the reactants? Let me make this one wider. Enthalpy of the reactant is greater than that of the product. So what are the reactants? Hydrogen gas and iodine vapor. So hydrogen gas plus iodine vapor. These are the reactants. What is the product? 2 moles of hydrogen iodide is the product. Now, the difference in enthalpies is gotten here. That is, this level of energy, this level is enthalpy of the reactant. The difference now, the difference in enthalpy, we now give you enthalpy of the product, which is smaller, minus enthalpy of the reactant, which is greater. And that's why we have negative. So you represent what is given in the question. So change in enthalpy will be minus 13 kilojoules per mole. This place from here to this point, from here to this point is called activation energy, EA. And at this point is called activated complex. So this is the representation of the reaction. So you can make this simpler and understandable by telling us what AC means, where AC means activated complex. That is what is formed before the product is finally formed. Is at the midpoint. And where EA is the activation energy. So this is the energy profile diagram for this reaction. If you are asked this kind of question, this is just the representation. So have a nice day. See you in the next class.